This lesson is on section 3.2 in your Algebra 2 text on complex numbers. If you have your textbook, go ahead and open up to page 128. If you don't have your textbook, you can print the pages from the bit.ly/Google Math login, or you may just take notes in your spiral as we work through this section. So a complex number is a combination of a real number and an imaginary number. So if A is any real number and BI is the imaginary part, when we add those two together, we get a complex number. So a real part and an imaginary part. So for example, 3 is a real number plus 4i is an imaginary number. Add those together and you get a complex number. So these are all three examples of complex numbers. So in our number system now, real and imaginary numbers are in the overall umbrella of complex numbers. So we have real numbers like these, we have imaginary numbers like these, and then when we combine those together, we get complex numbers. And so we need to be able to do all operations like addition and subtraction and multiplication of all three of those different types of numbers. You already know how to multiply and add real numbers, but now we're going to look at complex numbers. And so in example 1a, they're just asking you to identify the two parts, the real and the imaginary part. So for this one, the real part is 9. And the imaginary part is 5i. So this is real, and this is imaginary. So the real part is 9, the imaginary part is 5. So for example B, this only has an imaginary part, so our real part would be 0. So the imaginary part is negative 7i. The real part is 0, and then the imaginary part is negative 7i. And this number belongs to the set of complex numbers because it's real plus imaginary, but it also has just an imaginary part only, so it's also part of imaginary numbers. So if you take the problem, the number 11, 11 has only a real part. There's no imaginary part, so we could say plus 0i. And so the real part is 11. The imaginary part is 0i. And so this is a complex number. And it's also just a real number because the imaginary part is 0. Go ahead and try problem number 5. Identify the real part and the imaginary part and name what sets it's part of. This part is real. The part with the I is imaginary. And so our real is negative 1. Our imaginary is 1i. And the set, that number is only complex. It doesn't fit under real, it doesn't fit under imaginary. It's a combination of the two. So this fits under the set of complex numbers. Okay, and then the next examples are on adding and subtracting complex numbers. So when we add and subtract complex numbers, we just add the real parts and add the imaginary parts. So negative 7 plus 5, those are the real parts. That adds up to negative 2. 2i and negative 11i adds up to negative 9i. So we get our simplified answer of negative 2 minus 9i. In example B, again, if we just add the real parts, 18 minus 2, because it's subtraction. 18 minus 2 is 16 for the real part. The imaginary part's going to be 27i subtract 3i gives us 24i. So we did, again, 18 minus 2 for the real part, and 27i minus 3i is 24i. So there's our final simplified answer. So go ahead and pause your video and try problems 7 and 8, and press play when you're ready to see the solutions. For number 7, if we do 17 minus 9, those are the real components. 17 minus 9 is 8, and then negative 6i minus 10i is negative 16i. For problem 8, if we add the real parts, 16 add negative 8, that gives us positive 8. The imaginary parts, 17i plus negative 12i is 5i. Then in the next section, we're going to multiply complex numbers. So we multiply these very much the same way that we multiply binomials. Like if we were doing x plus 2 times x minus 5, we would multiply using the FOIL method. That would give us x squared minus 5x plus 2x minus 10. So when we combine the middle terms, we get minus 3x minus 10. You could also do the box method. We did x plus 2 and x minus 5 using the box method. This would be x squared. X times 2 is 2x. X times negative 5 is negative 5x. And negative 5 times 2 is negative 10. Then we combine these. We get x squared minus 3x minus 10. Same answer, but by using the box method. So in example A, we distribute, we get 24 minus 8i plus 54i minus 18i squared. But remember, I squared is just negative 1, so this is actually plus 18 because I squared is negative 1. So we get 24 plus 18, those are the real parts. And then if we combine the imaginary parts together, that is going to be 46i. And so 24 plus 18 is 42 plus 46i. Okay, example B, this time I'll use the box method to demonstrate that. So if we have negative 3 and 12i and 7 plus 4i, when we multiply those, we get negative 21. Then we get 84i minus 12i and 48i squared. So when we combine these together, we have negative 21 plus 72i. 48i squared is 48 times negative 1, so that becomes minus 48, because remember, I squared equals negative 1. And so then that gives us negative 69 plus 72i as our final answer. If we use the FOIL method instead, we'd get minus 21 minus 12i plus 84i plus 48i squared, and this is minus 21 minus 12i plus 84i plus 48 times, remember, I squared is -1. So then putting the real parts together, we get minus 69 and then plus 72i. Okay, I'd like you to try problems 10 and 11. So pause your video, multiply those out, press play when you're ready to see the solution. This one I'll do by the FOIL method. 6 times 3 is 18. 6 times -10 is -60i. -5i times 3 is -15i. -5i times -10i is positive 50i squared. So that's 18. These combine to give you -75i. This is 50 times -1, so that's -50. And so when we put those together, we get -32 for the real part, because it's 18 minus 50, plus or minus 75i. Problem 11, I'll do using the box method. 8 plus 15i times 11 plus I. Here we get 88. 11 times 15 is 165i. 8i and 15i squared. So if we combine all those together, we get 88. These add up to 173i. And then this is minus 15, because that's 15 times -1. So if we add the 88 and the -15, that's 73 plus 173i. And that completes our lesson on section 3.2. Have a great day, everybody.